Hey everyone. So today we're going to do an interesting problem where we are going to try and sum two integers together without actually using any arithmetic operations. So let's go ahead and dive right in. And the first thing, as always, we want to do is ask any questions we might have of our interviewer. And in this case, a couple questions. It's good to always to clarify and make sure that you totally understand the problem. So by arithmetic functions or arithmetic operators in this case, we mean multiplication, division, addition, and subtraction. Obviously, you can't use addition because that would defeat the whole purpose, but basically we can't use those four. And presumably we also don't want to use other things like a power function or things like that, but clarifying these is a good thing to do before you start. So we're going to rule out anything that could possibly be construed as an arithmetic operation. So that includes powers, logs, all math functions, basically. So that is going to may tell us a bit more about what we actually need to do. But first, if we have any other questions, I also want to know what I'm actually going to do in this case if the integer overflows when I calculate the sum, right? Because in theory, we could end up with a integer overflow where we, normally if we did the addition, we'd end up with a really large negative number potentially. But I'm going to assume for the case of this problem that both of the integers that are passed in are going to be small enough that I'm not going to have to worry about overflow, just because it's going to make the problem a little easier. But it might be an interesting thing to think about how you would handle the overflow case. So let's get right into discussing how we're actually going to solve this problem. And what we can look at, really the best thing to look at, is that how we would normally do addition by hand. Like we did this in elementary school, right? Where you write out the numbers. You have like 123 plus 10 or something, and then you would basically sum the columns, right? So in this case, we get that the ones column is 3, the tens column is 3, and the hundreds column is 1. So that would be how we would do this in decimal. And the same thing can be done in binary. It works exactly the same way. So let's say we had, for example, the number 1, let's say 1001. And we're going to sum that with 0011. Obviously, this is the same as just 1, but I'm adding the extra zeros so it all lines up, and that'll hopefully make sense in a second. And we know that we can't use arithmetic operators, so that basically leaves us with using binary operators, because those we are allowed to use, like and, or, not, XOR, that sort of thing. And that's also why I'm looking at this in binary, right? Because we know that that's pretty much the only thing that we can do if we can't use any sort of mathematical functions. So we have to think about, how are we going to do this without the arithmetic functions. So if we were going to do this, you do addition exactly the same way in binary as you do in decimal. It's just that you only go up to 1, right? So, each digit is either 0 or 1. So in this case, we have 2 1s, so that would actually sum up to 10. So we put a 0, and then we have a carryover, because it's exactly the same as in decimal, where if it overflows, you just carry it over to the next one. Then in this place here, we have 1 plus 0 plus 1, so we end up with 0 and have another carryover. And so we get 1 there, and then we end up with 1 here and 1 here. And that is how we would do that. And so we can basically look at this as, if we want to look at this in terms of arithmetic operations, we can look at each column in terms of binary operations. We can look at each column in terms of a set of binary operations, because there are only a couple different combinations, right? We could have 1, 0. We could have the first number is 1 and the second number is 0. We could have both numbers be 0. We could have both numbers be 1, or we could obviously have 0, 1, but that's the same as 1, 0, so we can ignore that. And then in this case, the result should be, in the first example, if it's 1, 0, the result should be 1. And in the second case, the result should be 0, And in the second case, the result should be 0, and we also have to deal with the carryover. But we'll deal with that in a second. So we can see that this lines up exactly with the XOR operator, because we have 1 exactly every time that the two numbers are different. So like in this column, let's say we ignore the carryover for a second. In this column, we have a 0 and a 1, and so we would put 1 at the bottom. But of course, now we then have the carryover, so that no longer works. So we also have to deal with the fact that there's a carryover. And let's look at another way that we could do this problem that's very similar, and it follows the same logic, but is slightly different. So we have our numbers. We have 1, 1, 0, 0, 1 plus 0, 0, 1, 1. And what we're going to do is we're going to do so we could do this XOR, right? So we have 1, 0, 1, 0. And then we could also calculate the carryover and sum them together, because that's exactly what we're doing up here, right? We're summing this number. If you were to add, you could add a 0 onto the end here. We're basically summing this number to the sum, or to the XORed sum of these two, right? To the sum of these two where you exclude any carryover. So what we're doing here is we are taking the sum, and let's actually do this, and you can see that this works the way we expect it to. So we just XORed them, and then we're also going to calculate the carryover. So in this case, the carryover is going to be in this column here. So we calculate that we have 0, 0, 1, 0 because it carries over from this column to the next column. And then we can do the same thing again, where we're going to sum these up, and then we're going to have another carryover. So we're going to do the same thing we did before, where we're going to XOR them. So we get 0, 1, 0, 0, 0, and that needs to be plus the carryover. So in this case, we're getting carryover from this column to the third column. And so we're going to get that the carryover is 0, 1, 0, 0. And then finally, we can sum these up, and we get, again, we're going to XOR it. And so we get 1, 1, 0, 0. And that's exactly what we got up here. So hopefully that makes sense. By doing the carryover repeatedly, we are just using the XOR to tell us whether or not the value in that place is a 1 or a 0, and then we're going to calculate the carryover separately. So how can we calculate the carryover? Because that's an important question, right? And so let's say we're not going to include the carryover as part of the sum, because we're only summing two numbers at any given time. But what we want to do is from these two numbers, calculate this number, and from these two numbers, calculate this number, and so on. So we can do the same thing where let's just map out what we get, right? So in this case, we get that the carryover is 1 in this column, which if you look at it, the carryover is coming from the first column. So we're going to look at the column where the carryover is originating, and then shift by 1, because the carryover is always 1 to the left of the column that overflowed. Right, so we have an overflow in this column, and so it overflows into the next column here, and then we have an overflow in this column, so it carries over into the next column. But we are going to just look at how we can take the two numbers that we have and get the results. So we start with, we have 0, 0. If the numbers are 0, 0, then the carryover is 0. If the numbers are 1 and 0, or 0 and 1, the carryover is also 0. And if both numbers are 1, then the carryover is 1. And that hopefully makes sense, right? Because the only case in which we get carryover is when the two numbers sum up to greater than the maximum possible value in that column, right? So in this case, we have this sums up to 2, which is represented as 1, 0, and therefore now we're in 2 digits, and we have to have carryover. So this obviously so this one here maps to XOR, right? This is a nice XOR, and this one maps to the bitwise AND. And hopefully that makes sense. And then obviously we have to shift by 1 as well. So this is sort of like AND shifted left by 1. And we can actually code this up really easily, because what we're going to do is we're XORing them and calculating the carryover. And then we're XORing that sum with the carryover. And then we're XORing and calculating the new carryover. And then we're XORing that sum or that XOR with the new carryover, and so on and so forth, until, in this case, the only reason why we stopped is because the carryover is now 0, right? If we calculate the carryover from this, we get that there are no columns where there are 2 1s, and therefore the carryover is 0, and so we basically are breaking out of this recursion or this loop whenever the carryover is 0. So we could do this iteratively or recursively. I think it's a nice little algorithm to do recursively, so I'm going to do it that way. And we'll keep these. Yeah, I'll just compress this a little bit. But we can code this up, and it's not going to be very complicated code. We're just going to it's going to return an integer. And remember, we're assuming that we have valid input, basically, so I'm not going to worry about validation or anything. But it's going to take in an int a and an int b. And we're going to do this recursively, and so every recursive call, I'm going to pass in the current, like the partial sum as a, and the carryover as b. So what that means is that we're going to start by checking if b is equal to 0. So if b equals 0, then we just return a, because that means that the carryover is 0, and so a now represents the actual sum. And otherwise, we're going to say that the partial sum is going to be a XOR b, right? So int partial sum equals a XOR b. And the carryover is going to be a and b shifted by 1. So int carry is going to be a and b shifted left by 1. And then all we have to do is call this recursively. So we're going to say sum, partial sum, and carry. And that's, we have to return this. So return sum of partial sum and carry. And that's it. Like, there's not very much code in this question. It's just figuring out what the question means and how to actually solve it is a little bit complicated, but hopefully that makes sense. And let's maybe just do this example here that we've already done. So I'm going to go back. I'm going to get rid of all this. And so we end up with sum a. So a is going to be 1, 0, 0, 1, and b is going to be 0, 0, 1, 1. And so neither of them is equal to 0. So we do partial sum is going to be equal to a XOR b, which is 1, 0, 1, 0. And carryover is going to be equal to a and b shifted by 1. So it's 0, 0, 0, 1, but then we shift it by 1. So it's going to be 0, 0, 1, 0. And then we're going to call this recursively. So we get that we're going to pass in a, and which is now 0, 1, 0, 1, 0, 1, 0, and b is 0, 0, 1, 0. And therefore, neither of them is equal to 0. And so we do a XOR b, which is 1, 0, 0, 1. And we AND them together. So that's 0, 0, 1, 0. And we shift that by 1. So we shift that, and then we get 0, 1, 0, 0. And we sum them one more time, or we do this operation one more time, 2 more times, I guess, because we're going to have the case where the carryover is 0. So we have a is equal to 1, 0, 0, 1, and b is equal to 0, 1, 0, 0. So we XOR them, and we get 1, 1, 0, 0, 0. Sorry, this should be 0 here. 1, 1, 0, 0. And the AND of these is just going to be 0, 0, 0, 0. And even if you shift it, it's still 0, 0, 0, 0. So we come in here one more time. B is equal to 0 because B is this. And so we return A, which is our sum. And that's what we calculated before. So that's all there is to this problem. Hopefully that made sense. It's pretty tricky. If you have any questions, feel free to let me know in the comments below or on the blog, or send me an email or tweet at me, or however you want to communicate with me is totally fine. And I look forward to seeing you again soon.